This presentation, we're just going to kind of talk about the point-in-time problem and looking at how we're going to teach our robots new tricks, the issues that we encountered during this whole process, so our startup taxes, context windows, and how those bottlenecks came into play, using the AI to parse and deal with large log files, and then how we actually implemented it all, and a demo. Fortunately, because the Wi-Fi here sucks, it was going to be a live demo, but I have to do a video so we can go through it. Now, I will say, full disclosure, I work for Lima Charlie. If you can't tell, this is not a sales presentation. I don't do sales presentations. This is just going to be talking about what we went through, how we did it. Everything that we did is open sourced. There'll be links at the end of this for all the repositories. Encourage you to go check it out, try it out. You don't have to use our platform for all this stuff. You can actually point your AI to something else if you want to. You can point it to Palo Alto's. You can point it to any other SIM, share platform, anything you want to. So don't think that you're going to sit here and just listen to me talk about Lima Charlie. It's not what I do. With that, whoops, sorry. I told you, I warned you there's bad jokes in here. Yeah, senior solutions engineer. I've been through the ringer, so I've been a CISO, I've been a consultant. All those things that make us great at our job. I've had the wonderful experience of getting to do those things. I even have some CVEs under my belt. So back in the day, I used to be a pen tester. I prefer the blue teaming. Pen testers are great, but I like to catch the bad guys. My spare time, I do a lot of the smart home automation. I am very big on privacy and making sure things don't connect to the cloud. So my smart home is actually off the grid. No cloud connections, and I've got like 40 something different light switches, and none of them talk to the cloud. I also like to play with espresso devices, so ESP32s. Any of you have seen those green badges? Those have an ESP32 on them. They're great little things. They're cheap. You can get them from China. You can do so much stuff with them. And then, because I was asking my kids, what do you think I should put on here? They just said, old bald guy. So they're all happy now. I will also admit I'm a former AI skeptic, and I still am an AI skeptic. I think there's a lot of hype about it. For those of us that lived through the .com bubble, we saw like .com and everything is going to be on the internet. Pets.com. And then all of a sudden, most of it went away. That said, about 4 or 5 months ago, when we started doing this, I actually found usage for it. I thought, hey, this is a lot better than just generating images. This is a lot better than writing a paper. I can actually use the tool to do things that 10 years ago I was promised other tools would be able to do. What's the problem here? LLMs are stuck in the past. When an LLM is trained, there's all that data available to it up until the day that it's trained. After that point, it doesn't know anything else. So what that means is anything that's going on operationally, it has no idea. Like I said, it's great for developing software. It's great for writing papers, for creating images. It's terrible at operational use. And for Lima Charlie, we are a security operations platform. The whole idea is operations. We need to be able to do stuff with the tools that we have available, and we need to do it at scale. So as an example, Black Hills is one of our customers. Thousands upon thousands upon thousands of customers of their own. They can't just go and do one at a time. They need to actually be able to do things quickly across all those customers. And so we had to implement something that would actually work and in a production level environment. And so that's what we built. So to start off with, those that aren't familiar, there's a thing that Topic released 2024, late 2024. They open sourced it in 2025 called the Model Context Protocol. What that does is it actually lets your robot talk to tools. So it's talking to external tools. I'm not talking about command line tools that are on the system itself. We're talking about hitting APIs. We're talking about hitting other data sources. It'll even tell it how to talk to a carrier pigeon if that's your data or your data transfer. All the operational stuff that you need to do is what it actually allows you to do. There are 3 parts to it. The MCP protocol will actually tell it error handling, input and output, how to talk to the tool, and actually what the tool does. So your AI can actually go and look and say, I need to go research X, Y, and Z. They'll hit that MCP server and it says, hey, here's all the tools I have available to you. There are 3 parts to it. So you've got the host, which is going to be what most of us work with. So that's going to be your Claude code. That's going to be Cursor, your development environment. That's actually what we're interfacing with on a regular basis. You have the client, which is what talks to your MCP server and will keep that connection available. And the MCP server is what tells the AI how to do everything. It's what's saying, this is what I have available. Here's how you use my tools. Here's how you do everything you need to know. So what are the benefits that it gives you? Now, I can actually go and create databases. I can FQ commands. I can go and hit APIs that weren't available to me before. If I want to, I can launch nukes. That not too far off at this point. If you see that we now have AI in DoD, what else are they going to give it access to? I will give a caveat to this. The native CLI tools are going to be better. As an example, if anyone's ever used the GitHub command line, that uses about 100 to 200 tokens. If you're using the MCP server, that's using about 26,000 tokens. Those CLI tools will always be better. They're local. You don't have to describe everything, and they can just, your tool can go and grab that it needs to. So it can go read the help file for your tool, for your tool. And there's other ways around it, so you don't have to use an MCP server. One of the things I'll talk about is Claude skills, which kind of define the same thing. But the MCP server is what gives you that standardized way of talking to it. So just kind of showing all the different things you can throw into it. Anything you want to. So I use Proxmox at home. I've got a Proxmox MCP server so that I can talk to my Proxmox systems and spin up VMs as I need to. There are a lot of them that are coming out now. There's a few hundred or close to 1,000 of them, and because people are just vibe coding them and throwing them out there. So we learned this. We're like, cool. We're going to go build a nice big MCP server, and we're going to profit, and everyone's going to love it. It didn't work. We have this is 120. The AI told me it was 143 actual APIs. That's a lot to shove into an MCP server. So what would happen is we put all that in there, say, here's how you use our APIs, and then it goes and reads that all at one time. Problem is, we were burning 50,000 tokens on startup. And I'll talk to you why in just a second of why that's a problem. So we defined everything, and we said, hey, this is how it all works. Go use it. It was a lot more complex than that. It got slow. It got stupid. It started making mistakes. And again, we're trying to offer this to our customers. We're making this open source. We can't have that level of problems. When you're doing an investigation, when you're trying to deploy rules across 100 different customers, you can't have mistakes. They need to all be consistent. Context window is like the working memory of your AI. The whole idea is, as I mentioned, your LLM is trained on the data up until the point that it's trained, and then past that, it doesn't know anything else. If you want to give it more information, it stores in the context window. That context window fills up, and that's everything that you have done. So everything that you've talked to with your AI, when you start it up, conversations, the input and outputs, all of that goes into your context window. And as it fills up, it gets slower, it gets dumber, it starts making mistakes, and you start running into a lot of issues. For Opus 4.5 and 4.6 for regular users, not developers, context window is 200,000 tokens. Remember I mentioned we burned 50,000 tokens on startup? We're already under the gun here. And that doesn't even include the tokens that are burned by Claude starting up on its own. We had to figure out something different to do. For anyone that's not aware, kind of just as a rule of thumb, one token is going to be about 0.75 words. And we're just talking like regular human words, not like byte words. So if you think about it, you stick a log file in there, each line is going to cause it to use more and more tokens. Each time you run through that context, each time you do something, it's adding to that context window. I stole this little diagram here from Anthropic. This is kind of just showing what happens with your context window. So each cycle, each time you're doing it, it's adding to it. So you've got your prompt, you've got your tool uses, you've got your input and your output, that adds to it. Everything goes into that context window. There are skills and options so that you can compact it, but you still have that 200,000 limit. With Opus 4.6 for the developer version and kind of the enterprise versions, you can get a million token context window. But we'll talk about why that's not necessarily the greatest thing. You still run into a lot of weird issues with that. Tree. So I mentioned like when you load up Claude or load up any of the other tools that you're already burning tokens. So that's what they call the startup tax. You have MCP servers that Claude is using, and I say Claude, but the whole idea is you could do this with Codex, and then with Google's whatever they have, or apparently Grok, because pen testers are using Grok now, as I learned last night. That one, I don't know, all right. But each time it runs, it has to read that instruction manual. So if you think back to when I said, hey, we threw all of our APIs at it, we gave it like a 500-page instruction manual, and then every time it starts up, it reads that manual, and it sticks it in memory every single time. That's not efficient. It's not going to work. We've got to do something better. Just as an example, without any MCP servers, without anything loaded in, this is my context usage for Claude, just starting it up. So you see, I've already got 31,000 tokens burned with nothing, like literally nothing. That was just plain Claude. We need to do something better. Anthropic came out with a article last year of what they saw was happening. They were seeing 33% of the context window for developers was burned up just on those tokens, just on MCP servers, starting it up before anyone has written a single line of code, before anyone's created any prompts. You're already gone. So you got to do something better. Now, might think, all right, let's just make a bigger context window. And they did. You get into issues where the more you shove into it, it gets a little confused. So I'm not saying anyone else here has done it, but in high school, I would read a book the night before I had a test. And I can tell you, I might remember the beginning of it, I remember the end. I have no idea what's in the middle of it. You ask me the story or the characters, I don't know. That's what the AI does too. It has that same problem. So if you have that 1 million context window and you fill it up, it's gonna pick the stuff at the beginning. Definitely will get the stuff at the end of what you sent it, but the stuff in the middle, it miss it. And again, like I mentioned, we're trying to do this for production, we're trying to do this for our customers. We can't miss things. So that 1 million context window is not always better. Plus it costs more money. I don't know if anyone has seen the price of RAM lately. Exactly. Memory is expensive. And when you're looking at a context window, that is actually sitting in RAM on these LLMs. So they don't want to give that to you either, unless they're going to charge you a premium for it. You also have the other issue of there's more latency. So again, you have a million tokens in there. That's a million tokens that the AI has to run through to answer your questions, to answer your prompts. It gets slower and slower and slower. The other fun thing too is that we found out, and kind of research is supporting this, after about 50%, it starts doing weird things. It'll generate weird errors. It'll give you answers that don't make any sense. It'll make mistakes. So that 200,000 token context window is really more like 100,000 if you want to be able to use it. I will caveat this. I am not an LLM expert. I am not a researcher. I am stealing research from other people, and all the links are at the end of this to verify and validate this. So don't take my word for it, but kind of this is what the research is showing right now. You see, as time progresses, we're getting bigger and bigger context windows, but those issues still come into play with it. Yeah.
What's your opinion on a context window that moves the conversation kind of like a stack?
So they right now, they do that in a way of they summarize it. So what they'll do is, like if you go into Claude, you can actually compact the context window. All it's doing is creating a summary. But when you create a summary, then all of a sudden you're losing the original information. So when you summarize something, that detail that might be really important, especially if you're going and saying, hey, show me all the systems that have port 22 open, that it gets a lot narrower. And then if you're moving it, then you lose that information at the beginning. So that's the challenge of it. That's the challenge that these AI companies are facing right now. It's what we had to fight through. Now, we worked through it in our own way. I have no idea how the AI companies are dealing with it. One thing I want to mention is, so Claude did come out with what's called Claude Skills. Open AI Codex has implemented their version of this. They are not 100% compatible with each other right now. Everything I'm going to show with this, I'm actually, next week, I'm going to start playing with Codex and trying to get this moved over to Codex as well. The idea for us was, we're not selling Claude. We're not selling AI. We're just giving people tools to use. So we want them to be able to use any tools they want. For me, that's, all right, someone doesn't want to use Claude. There are other tools out there like OpenAI's Codec. I don't remember what Gemini's code tool is, but we want to be able to have them all interoperable. So we didn't do anything that was, we tried to stay away from anything that was very specific to a specific LLM. That said, we did use Claude Skills. And for anyone that's not aware of what Claude Skills are, it's just a markdown file that says, here's how you do everything. If you have a prompt that you want to do an analysis on a file, and each time you do that analysis, you want it to do A, B, C, D, and E, you don't have to type that prompt out every time. So you just stick it into a skill. You say, when I go to do this analysis, I want you to do A, B, C, D, and E, and I'm just going to tell you to go analyze this file. And it'll do it. Gives you consistency, makes things faster, and it gives you a predictable output, usually. And I just say usually because AIs do weird things. When I was preparing for this and trying to get the demo to work, because I was going to do a live demo, it changed every time. So the skills are what give you that, try to narrow down that output. I do want to give a part to Anthropic. So in November of last year, they came out with what's called the tool search tool. And the idea is your AI can go and actually query the MCP server and comes back with information, and it's searching for a tool. The problem that we found with it is it wasn't that accurate. So this is just an example of that there are two ways that the tool does the searching. One is regex, and the other one is best matching 25. With the results that we saw personally, and then this is kind of just what someone else is seeing, that wasn't good enough. If it's only working half the time, then I have angry customers that are like, why is this not working? You promised us tools that would work. So that's part of why, it's a big reason why we built our own, and why even to this day, we still have not moved over to the tool search tool. The other thing is too, I mentioned that we want it to be universal. We want it to be cross LLM. The tool search tool is Claude specific. So if we had done that, then we would be forcing all of our customers to use Claude. And some people don't, especially if you have a large enterprise and they're set on OpenAI, then eliminates that whole customer base. So we did, for anyone that, any software developers, we implemented progressive disclosure, also known as lazy loading. And you may not know what it is, but I guarantee you everyone here has dealt with it. If you go to Facebook, you go to Twitter, and you're just scrolling through, and it's loading up as you're scrolling, that's lazy loading. It's just showing you what you need at the time, and when you need more information, it'll give it to you, but just a little bit so that you don't have to fill up in memory. If you think about like going to Twitter and it didn't use progressive disclosure, you'd have your entire timeline and it would load up and Chrome would crash faster than it already does. So we implemented it, and we put in a thing so it said, this is what you search for. You go use the meta tool, and the meta tool will tell you what you need. Then we use the Claude skills to define how you talk to those tools and how you go and get more information. And it filters it out so that you're only seeing what's available or what you need at the time. You don't need information about everything. So we're like, cool, all right, fixed. Now we're ready to go. This all works now. Until you try to actually load those files into that context window again. Turns out, again, robots don't like their memory filled up. What we were seeing is detection rules. So, for example, if I wanted to go through and say, show me all the detection rules and tell me what they do in my environment, I was taking up 100,000 tokens already. Lookups, so if you had a list of Tor nodes, and you told it, I want to know if this IP address is in that list of Tor nodes. It was burning 200,000 tokens. We're already out our context window. You want to read the log file? I will not guarantee the accuracy of this, but I had Claude estimate that. For a 10 meg log file, you're talking about 2.6 to 3.5 million tokens. There's not an AI or LLM out there right now that can handle that. So we had to figure out what to do with it. How do we handle the data? How do we make it available to the LLM and still useful without breaking it? I say storage is cheapish. Like memory, storage has gotten more expensive. So it's still cheaper than memory, but I'm really glad that I built up my lab server at the beginning of last year instead of at the end of last year. Side note, if anyone hasn't looked at RAM prices, my 64 gigs that I bought at the beginning of last year for $200 is now $850 for the exact same sticks. It's insane. So if anyone's trying to build a computer or buy one, I'd wait. So how do we handle this? Well, we are a cloud platform. We run in the cloud, we live in the cloud, that's all we do. Why not use the cloud? Why do we have to take that data, 10 megs of log files, and load it into memory? That 10 megs, we're not gonna need all of it. We only need the little bits and pieces of it. So why don't we just figure out a way to chop it up and only send to the LLM what's pertinent? So what we did was we take that data, and instead of outputting it to the LLM, we stick it in the cloud stores. It's just a temporary location. We send the URL back to the LLM, say, all right, here's where you go get the data. Download it. Don't read it, just download it. So it'll go and use curl, grabs files, drops on the system, and it parses them there. That way, you're only working with data on disk. And again, it's ephemeral, so that URL, as soon as you're done with it, it goes away. The data on the disk gets deleted when you're done processing it. It doesn't stick around for you. Helps bring down the context usage, but then we found other problems. So just as an example, like this is kind of how we built it out. So what we built out was, if the file is large, the LLM will, or the MCP server will actually return a URL to go download it. If it's small, then it just goes straight back to the LLM. That way, we're not adding the extra step in there for small stuff, and it's actually being deterministic of, this is how I need to handle this large data, this is how I can handle the small data. So if I'm just doing a quick query saying, hey, what systems are online, that's gonna be a small amount of data. It can go back, be processed, stick in the context window, no problem. But if I'm saying, I wanna know all the systems that have connected out to an outbound port, or sorry, to an outbound system on port 22, that's a lot of log files. So at that point, that's when we're gonna return the URL. It's gonna download it and actually work on it on disk. We got to a point where we're like, yeah, cool. We figured that part out now. Except now we have other problems. It gets slower. What we were doing is we were having the LLM use things like the JQ, so JSON query, grep, bash, sorry, not bash, strings, all the stuff that we have on a standard Linux system. And it works. But it keeps doing it over and over again. And if you remember back to that image I showed from Anthropic, each time that happens, more gets added to your context window, more gets added. And so it keeps doing it over and over again. So we had to figure out how to do this at a faster pace. If you're doing an investigation, you don't want to wait 5 hours to run the query. I can do that myself. What's the AI giving me benefit for? It got really, really slow. It worked, but each time was more context added to it. And even though we were using those local tools, it still had to send the data to the tool, read the data back in, figure out, was this right? Do I need to do more parsing? And each time adding to that context window. And then all of a sudden, you have your full context window, you're compacting it, you're losing that, we're talking about the summary, you're losing that detail that you need. Great thing is we have these things called subagents now. So for most of us, like I'm using Claude, I'm using Opus. The great thing about Opus is, great for reasoning and thinking, terrible speed, and it's expensive. For anyone that hasn't looked at the pricing of the LLMs right now, especially for like developers, you can get a Claude subscription for $20 a month. You can get a better one for $100 a month. The reality is they're losing money on those every single time. So we want to look towards the future. We don't want to create something that's going to work now and then in 6 months, especially with how quickly AI changes and the LLMs are changing. We need to make sure that we're able to scale with it. So that's why we started using these subagents. For really in-depth thinking, we're using Opus or whatever your model is. So if you use Sonnet on a daily basis, that's what we use. That one is based on what you choose. But you're going to do things like your detection rules, your analysis of events coming in. But you don't want to do analysis of all the data, or even just figuring out what's going on. Is this file malicious? And then you use the interns for the quick and easy stuff. If you're using like Sonnet, it's going to be cheaper and it's going to be faster. That's great for doing things like going and grabbing the files and parsing those files out, doing the really easy stuff that, if you think about an intern, you don't want them to do the smart things. You want them to do the easy stuff that they're there for and they're going to learn.
So are you saying that if you have an LLM implementation for some security analysis test, the specific tool you use, you should specify, let's say it's an AWS Bedrock, you should say use Opus 4.6 for the tool you use. But for the file acquisition or data object, the get S3 object like you saw in it?
Yeah, exactly. And that's what we did. That was how we implemented, because again, I want to use Opus to do the really in-depth stuff and the high-level reasoning, but it doesn't need to go grab the file for me. It's going to double the amount of time that it takes to actually just grab the file and process it. Sonnet is a lot quicker at that, but Sonnet doesn't do that high-level reasoning.
Gotcha.
So with that subagent, all it's going to do is return the data back, that small amount of data that we have. It's a whole huge thing. So what we built out with it was we're mixing and matching. Why do we need to use Opus for everything? Why do we need to use Sonnet for everything? Use the right tool for the job. So we have specialized subagents, and all of our subagents at this point are using Sonnet, and I'll tell you why we're not using Haiku in just a second. But they're specified, use Sonnet, here's what you're doing, here's your job, go do this, and then send the data back to me. Sonnet is really good for writing shell scripts. So again, to parse it out, if it doesn't know how to parse it itself, it'll just write a script to do it for you. It'll generate a Python script, a Bash script, and then it parses out the data. You're not doing anything, it's doing all the work for you. And at that point, you only send back up to your main models, to Opus at this point, of what's relevant. Now, originally we had used Haiku because Haiku is much faster and cheaper. Problem with Haiku is we were getting a lot of hallucinations, a lot. I had not updated all my code from our GitHub repo. And last week, as I was trying to prep for this and record the demo, it told me that I have FreeBSD, Solaris, and all these other things on my home network. I don't have those. I told it to list out all of my customers, all the organizations in my tenant. At one point, I actually thought we were leaking data because it started hallucinating. It made up organizations I'd never seen before. And I was like, are these customers, do we have a data problem? Nope, it was just making stuff up. So again, I can't have that in production. Our customers can't have that. So we switched everything over to Sonnet. And once I updated my repo, I was fine. It all worked. All those hallucinations went away. So then we built out this one big meta skill. We call it the Lima Charlie call skill. The whole idea is that skill is going to be the only thing that the LLM knows when it starts up. It's going to call the MCP server and say, what can you do? It'll give it a brief overview of about 10 different skills of here's what's available to you. If you need more information, let me know. Good. So Opus comes back, looks through those skills, says, all right, I want to go read a log file. I want to go query data for the past 7 days. All right, well now I need to do a query. So we'll go ask the MCP server, how do I do a query? It responds back with, here's the skill that you need to do. So we're going from 140 tools down to 3 tools that it knows about at the time. And then it can always reach back and get more information as it needs to. It's not stuck on, this is the only thing I have available. The cool thing is too, because it is Claude code and it's writing scripts and stuff, if there's something there that it doesn't know how to do that we haven't defined yet, it will actually go write a Python script, read the API documentation and say, all right, this is all I have to do. And goes and does it for us. Okay, because Claude code is good at writing code. It does it without any problems. And then the sub-agents do all the real work. So we're just, again, using that Opus or the big model for that high-level reasoning. That's the really important stuff. And then having the sub-agents do all the really grunt work that isn't as deterministic, but also is important to feed that large model without blowing things up. So the impact of this, before that, like I mentioned at the beginning, we were hitting 50,000 tokens burned, and that was just starting off. As we added more data to it, as we added API endpoints, it got bigger. We've reduced down to 80 to 90% usage at this point. It's faster, it responds back to us, it's more deterministic, it's not hallucinating anymore, it's giving us the relevant information, but it's only giving us what we need. And it's a lot more useful at scale. So when I say at scale, again, if you have 1,000 customers, it's able to go and hit all the 1,000 customers and get you the information that you need and actually give you relevant data. I did mention this is all open source. We are big proponents of open source software. We love it. We've also open sourced some other tools just recently called Vibrails that puts in guardrails for vibe coding so that you're not taking down production systems. We believe fully in open source. We want to share it. People are wondering, I've been asked, why aren't you selling this? We're not selling anything. The whole idea is we have a platform available. We want people to use it. These tools are universal, and with how fast everything changes, why would we do that? We want to give it out, have people improve on it, share it, and build your own stuff. So, and I think all these slides and stuff will be available online, but if you want to, here are the things that the open source repositories that we have. One of the cool tools that we released a few months ago was LCRE, so it's our reverse engineering CLI. If anyone's messed with the Ghidra MCP server, you actually have to run Ghidra and then do all these weird things loaded in scripts, and again, you start getting into context window problems. We built a wrapper for it, so I can actually go and start reverse engineering malware using Ghidra headless, and it sends all the data back, and then I can use that for my production system. So I can say, go analyze this malware, and then go create rules to detect it. And it does it. Then also documentation. So everything I've talked about is available. There's nothing special or hidden. And feel free to go look at it. So the question was, MCP gateway, so reducing the size of everything. And that's basically what we did. That's kind of what the Anthropic tool search tool is. Same thing for us. We just call it a meta skill. What it is, the whole idea is it reduces the amount of tools that it needs to worry about at one time. Yeah.
So when the sub-agents finish the task they're assigned, do they just automatically release the context, or is that the end of the sub-agent, that particular one?
They all have their own context. So if you have 10 Claude windows open, you're probably bogging your system down, but each of those has their own context window. They're not sharing it. So if I have 10 sub-agents that get executed, each of those will have their own context window as well. So I don't have to worry about filling up my main context window. They're handling it all on their own. This is a long prompt, so I'll just quickly explain what it's doing. This is kind of the thing that I've been playing with lately. It's kind of fun. I went on Malware Bazaar, grabbed a random piece of malware and said, hey, go analyze this. I want you to not only analyze it and figure out everything that's going on, I want you to reverse engineer it. I want you to go create new rules within our system. And again, you can do this with Bro, you can do this with anything else. As long as the LLM knows how to communicate with your tool, this will work. And then I want you to verify it by actually going and spinning up an Azure VM, running the malware on it, stick our agent on there so we can view it, and then make sure it works. And if it doesn't, go back and fix it. So you can see what Opus is doing is actually gone through. It says, all right, these are the things I need to do to make this work. Here's what he's requesting of me. Here are the different tasks I'm going to do. And each of those is going to spawn additional sub-agents. And it will actually do things in parallel. So as long as you tell it to, it will go and actually say, I can do X, Y, and Z at the same time, but I'm going to be blocked by tasks that are still going on. So if you look, you have those at the bottom. It says blocked by number 2. So it's actually keeping track of everything it needs to do and everything that has happened. Here, See, it used Ghidra and actually went through and I told it to decompile it, or it's decided it needs to decompile it. It's using the tools I have on the system. If I didn't have these tools, it would use what's available. There are times when it will try to install things. If it doesn't work, then it just skips it. It goes on to the next thing. That's kind of the cool part. Honestly, it doesn't just error out. It figures out a different way of doing, of accomplishing your task. And you see it's already figured out this is a .NET binary. So at this point, it's actually going into Lima Charlie. It's going to go and set up everything it needs to so that we can grab the data and see what the malware is doing. I have the meta skill. So you can see here, we're actually the LC call tool. We're using that meta skill to figure out what we need to do. And it's already reducing how much we're using. We're at 1,000 tokens instead of 50,000. And it's going to increase as we do more analysis, as it keeps running through it, and it's iterating every time. So we want to keep that usage low. And then you can also see the VM is ready. So while it was doing the analysis, Azure was spinning up a virtual machine so that we could have that ready to go execute the malware on. And this is all done just in Azure because that's what I have access to. I've done it in Proxmox. You could do this with GCP because, again, this is actually using the local Azure CLI tool. It's not using an MCP server. It's not using anything special. This isn't something that Lima Charlie offers. This is literally a demo environment that I have. So make sure, especially if you're running malware, that you're not doing it in production systems, or production resource groups. I told this to create a specific resource group for this and then delete it afterwards, just to be safe. And then here, you can see it's even running a bash command. So all it's doing is, at this point, we've got the VM up and running. We've got everything going. Now we need to install an agent on there so that we can monitor what's happening. And that's where it's doing it. I haven't done anything here. All I did was give it that prompt. It's figured all this out on its own. It's read the documentation. It's gone and said, all right, these are the steps I need to do to install the agent. These are steps I need to do to actually deploy a VM. These are steps I need to do to actually go and reverse engineer the malware. And it's figuring it all out as it goes along. So now here, we've got our agent installed so we can monitor everything that's going on. We've uploaded the malware. Now we need to execute it. And the cool thing is too, if it's too big to send as like base 64, the AI will go and figure out a way to get it onto the system. So if I had a larger piece of malware, it actually will go stick it in a storage bucket and then download it onto the system using PowerShell with the Azure commands. Again, I'm not doing anything here. I'm just sitting back and watching. And now you can see we've executed the malware. Right here, it's running. We now have malware running on a production system, well, not production, on a demo system. And as far as it knows, it's just a regular old Windows system. It's executing like normally. It's not worrying. Even if the anti-debug and anti-analysis hooks that are in malware, it doesn't know any different. So it executes flawlessly because these days, especially most things are virtualized, especially if it's a server. It also knows that the data needs to come back to the system before it can, or come back to our tool, to Lima Charlie, before it can actually search for that data. So it's going to wait. And then now at this point, so we've got rules on Lima Charlie. We've executed our malware. Now it's gone back and looked within Lima Charlie to make sure that it has executed and that the rules fired. Rules are great, but if you don't know that they work, you don't want to find out at the wrong time. This is a great way to figure out, did my rule work, or are the things that I need to fix with it? And so it'll go and make those analysis. And if it didn't fire, the cool thing is too, it'll tell you why. It'll say, look, I couldn't fire. The C2 server is down. This rule won't fire, but it would have if the C2 server had been up. The other thing too, the completely side note that's pretty cool about this is this was actually an encrypted piece of malware. And Claude was able to figure it out on its own. It went through and was able to, try to find it. There we go. Yeah, see? It's an encrypted configuration. It's able to go and find the encryption key in the malware and decrypt it for you. Again, completely hands off. I had another piece of malware that I stuck at it that used a really crappy encryption key, and Claude just randomly brute forced it, and it worked. And at the end of it, it goes and cleans it all up. So now it's deleting the resource group, it's deleting the VM, nothing left over, and this took 23 minutes. The whole idea of this is not to, I want to be very clear, we're not trying to replace SOC analysts. I used to be a SOC manager. There is something inherent that good analysts have that you cannot train an AI on. There's gut feelings. Just when I was training my employees, they would ask me, how'd you know this was malicious? I don't know. It looked weird. Something that we can't train the AI. The whole idea with this is just to make it faster. These are all steps that an analyst is going to do anyway. Why make them do the same thing over and over again? Even pen testers, you've got scripts that you wrote to make your commands. Everything you're doing is the same every time. You're just going to run that one script to do it all for you. That's all this is doing. It's just another tool. I will flat out say, I do not believe that AI is going to replace SOC analysts, and I will die on that hill. It just is going to make them better, makes them more efficient, and makes them less bored. I've been an analyst before too, doing the same thing over and over again. Boring as hell. I want to do the cool stuff. I want to look at the new piece of malware that no one has ever seen before, not the same one that everyone else has seen that I have to now go figure out how to create rules on and detect on. And at the end, it gives me a report of everything I did. If I wanted to, I could tell it, hey, give me a report in Markdown or PDF format, and then take that and send it off to my manager. And here you go. That was all I had to do to get the report created. Obviously, you do want to go through and make sure that the rules are valid. You're going to have false positives. It's not going to be, it's not a panacea that it's going to solve all your problems. It's just a tool that's going to make you faster. You still want to verify things. But at the same time, I can say, hey, these are false positives, go fix them. Or even go look for false positives and then fix them so that I don't have to do anything. You can see, these are all true positives, 0 false positives. It looked for it for me. Here's my contact information. If you have any, this is a great time for questions, thoughts, flames, feel free to. If you try to reach out to me on Twitter, I probably won't respond because I don't go on there, but that's how you can reach me. If you have questions, I am a nerd. Even though I'm in the sales organization, I'm a nerd first. As you can tell, I like to design my own little electronic devices and stuff. If you want to talk about any of that, feel free to grab me. But thank you all for coming, and I appreciate your time.